Chapter 7, Section 3, Distance and Slope. The distance between 2 points, x1, y1, and x2, y2, can be found by using this formula. D is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So, for example, we're going to find the distance between these 2 points. Now, you may think, well, why can't we just plot them and count them? If it's a slanted line, you can't count the units, but if it's horizontal and vertical, you could. So, if we have these 2 points, we'll have x1, y1, x2, y2. And so we have distance is equal to the square root of the number that represents x2 is going to be 4 minus x1, which is a negative 5, so we'll have double negatives there, quantity squared, plus y2, which is going to be a negative 1, minus y1, which is going to be 3, quantity squared. So from here we're just going to do the math. Distance is equal to the square root of, double negatives go to plus, so we'll have 4 plus 5, which is going to be 9 squared, plus negative 1 and negative 3 is going to be negative 4 squared. Keep going, so we'll have the square root of 81 plus 16. So we'll have the distance is equal to the square root of 81 plus 16 is going to be 97. And 97 is prime, so there's nothing that you can do with that. If you wanted to turn this into a decimal, you could. And you would get we'll say 9.85 units. But if you wanted to leave it as a square root just at 97, that's fine. But if you come up with a radical, make sure it doesn't simplify, because if it does, I'll count off for not simplifying. Alright, let's try one more time. So we have the distance is equal to the square root of x2 this time is going to be 9, minus x1 is going to be 6, and we're going to square it, plus y2, which is negative 7, minus comes from the formula, a negative 4, which is y1, and we're going to square that. So we'll have distance is equal to the square root of 9 minus 6, we'll have 3 squared, plus negative 7 plus 4 is going to be a negative 3 squared. So we'll have the distance is equal to 9 times 9 is going to, or 3 times 3 is going to be 9. And negative 3 times negative 3 is also going to be 9. So we have distance is equal to the square root of 18. And again, that will break down. This will break down into 3 radical 2. And again, if you wanted to just do a decimal, I guess that's okay. You'll have 4.24 units. Okay, so slope. Slope of a line, we just found the distance between 2 points, and now what we're going to do is if we have those 2 points, we can find the slope of the line, and the slope is how much a line rises or falls from left to right. And so slope is understood to be rise over run, how many units you're going to rise and how many units you're going to run to get back to that line. So the slope of a line containing these 2 points, x1, y1, and x2, y2, can be found by using the formula M. M always denotes slope. Anytime you see M, just know that that's going to be slope. So M is equal to y2 minus y1 over x2 minus x1. So you have the difference of your y's over the difference of your x's. Alright, so find the slope of the line containing these 2 points. So again, you can label them if you want to, x1, y1, x2, y2. And so we'll have M is equal to, again, it's going to be the difference of your y's, so we'll have negative 2, minus comes from the formula, 3, y2 minus y1, over x2, which is going to be 1, minus comes from your formula, and you have a negative 4 as an x1. So, negative 2 and negative 3 is going to be negative 5. And 1 plus 4 is going to be a positive 5, so your slope is going to be negative 1, or if you want to do it 1 over 1, that's fine. Okay, so find the slope containing these 2. So we have M is equal to y2, which is 1, minus y1, which is also 1, over x2 minus x1. So you have 0 over negative 8, which is going to be 0. Alright, what if I give you a graph? Could you find the slope of the line on the graph? Well, what you need is 2 points. In order to find slope, you've always got to have 2 points. So there are plenty of points on this line. If I could hit them. There's one, there's one, there's one, and there's one. So to find slope, again, slope is how many you rise over how many you run. And so what you're going to do is you're going to go to a point, and we'll say point A, and we're going to count the rise over run to the next point, which would be point B. So we would rise 1 unit, and we would run 2 units. So your slope is 1 over 2. And you can use any point that you want to. If I chose to use, let's say, point A and point B here. Well, to get from A to B, I would rise 2, and I would run 1, 2, 3, 4. So that slope will reduce to 1 over 2 again. So the slope is still going to be the same no matter which points you use. Again, it's rise over run. How many units you rise over how many units you run. Okay, so applied problems with slope. If the ratio, and ratio is nothing more than a fraction, if the ratio of the rise to run, so we have a fraction of rise to run, which is your slope, on the pitch of a roof is 5 to 8, and the rise is actually 20 feet, what is the run? And so you're just going to set up a proportion. And so to solve a proportion, we would cross multiply, so we would get 5x is equal to 160. And then if we divide both sides by 5, we're going to get x is equal to 32. So that means that the run would be 32 feet. So let's try again. If the ratio of the rise to run is to be 3 to 5 for some steps, and the rise is 19 centimeters, what is the run to the nearest centimeter? So we'll cross multiply. 3 times x is going to be 3x, and 5 times 19 is going to be 95. If we divide both sides by 3, we'll get x is equal to 31.7 centimeters. But the directions say what is the run to the nearest centimeter, so we would have to round up, so that would be 32 centimeters. Okay, so if you're given a point on a line and the slope of that line, you can graph that line, and here are your steps. First thing you're going to do is you're going to plot the point, and then from that point you're going to count up or down depending on if your rise is positive or negative, and then you're going to count left or right depending again on whether or not your x is positive or negative, and then you would draw the line through the 2 points. So for example, it says graph the line that passes through the point 0, negative 2 and has a slope of 1 over 3. Well, first thing you're going to do is you're going to plot this point 0, negative 2, which is going to be here. Now, we need another point. To make a line, you have to have 2 points. So we would use our slope, and this is how many we're going to rise. We're going to rise 1 unit, and then we're going to run 3 units, and then we'll put a point. So we will rise 1 and run 3 from the point that I previously plotted. So I plotted the 0, negative 2 here, and then I would rise 1 and run 3. And then between these 2 points, I can draw a line. Alright, so that is distance and slope. So what I would like you to do is I would like you to complete these problems on page 372 and 373 and bring them into class if you have any questions.